Good day. Welcome to first lesson of the subject Mathematics in the Modern World. I'm Rudy Sabasa Divina and I'm here to discuss the first chapter. Let's first define mathematics. What is mathematics? Math is defined as the study of the relationship among numbers, quantities, and shapes. And math enhances our critical thinking skills, reasoning, spatial thinking, and creativity. Most of us, every time we try to answer a certain mathematical problem, we tend to think a way to solve the problem. And if the instance that certain way didn't work, we would find another solution again. We will never stop until we get to the right answer. And this is somehow mathematics help us to a better thinker. So let's go to our topic. Patterns and numbers and nature in the world. Patterns in nature are visible regularities of form found in natural world. What are the different patterns? Here's the natural patterns include symmetry, fractals, tessellation, foam, cracks, stripes, spiral. Symmetry. It means that one shape becomes exactly like another. Fractals. A detailed pattern that looks similar at any scales and repeat itself over time. Tessellation, a pattern that are formed by repeated cubes and tiles. Spiral is a curve which emanates from a point, moving farther away as it revolves around the point. Stripes. These are parallel patterns that commonly found in animals or things. So this is the example of each pattern: symmetry, fractals, tessellation, spirals, cracks, foam, and stripes. So that's the example of each pattern. Okay, let's move on to the next topic, which is Fibonacci sequence. Around 1200 AD, when Pisano or Leonardo of Pisa and 1170 to 1250 published the Liber Abaci or Book of Calculation, an arithmetic text concentrated mainly on Fibonacci computation and promoted the use of Hindu-Arabic numerals, the forerunner of today's familiar system, which use just 10 digits 0 to 9 to represent all possible numbers. One of the exercises in his book seems to have been Leonardo's own invention. It is written like this: a man put a rabbit in a place surrounded on all sides by a wall. How many pairs of rabbits are produced from that pair in a year? If it is supposed that every month each pair produces a new pair, which from the second month onward becomes productive. The Fibonacci sequence is the sequence F1, F2, F3, F4, and so on, which has its first two terms, F1 and F2, both equal 1 and satisfy thereafter the recursion formula Fn equal Fn minus 1 plus Fn minus 2. When continued indefinitely, the sequence encountered in the rabbit problem. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, and 377, and so on, is called the Fibonacci sequence and its term the Fibonacci numbers. And this is the table: months, 12 months, adult pairs, young pairs, and total. Leonardo of Pisa, also known as Fibonacci, discovered a numbers that created interesting pattern. The sequence is 1, 2, 3, 5, 8, 13, 21, 34, and so on. Each number is obtained by adding the last two numbers of the sequence forms what is known as a golden rectangle. A golden rectangle can be broken into squares the size of the next Fibonacci numbers down below. If we were to take a golden rectangle, break it down into smaller square based from Fibonacci sequence, and divide each with an arc, the pattern begins to take shapes. We begin with Fibonacci spiral, and which we can see in nature. Golden ratio. Fibonacci discovery of Fibonacci sequence happened to approach the ratio asymptotically. The Fibonacci sequence is series of numbers in which each number, Fibonacci number, is the sum of the two preceding number. The simplest is the series 1, 1, 2, 3, 5, 8, and so on. He found the interesting and mysterious properties of the Fibonacci sequence, that the series has a deep relationship with the golden ratio. The golden ratio was first called as the divine proportion in the early 1500s in Leonardo da Vinci's work, which was explored by Luca Pacioli, Italian mathematician, entitled De Divina Proportion in 1509. This contained the drawing of the 5 Platonic solids, and it was probably da Vinci who first called it the section aurea, which is Latin for golden ratio. Golden relationship between Fibonacci sequence and golden ratio. In mathematics, two quantities are in the golden ratio if the ratio is the same of their sum to the larger of the two quantities. The golden ratio is the relationship between numbers on the Fibonacci sequence. We're plotting the relationships on scale, result in spiral shape. In simple term, golden ratio is expressed as equation where A is larger than B. The quantity A plus B divided by A is equal to A divided by B, which is equal to 1.618033987 and represented by a Greek character. So, next topic is mathematics helps organize pattern and regularities in the world. Mathematics has helped organize pattern and consistencies in the world because one must know that there is always mathematics in almost everything in this world. mathematics will stay in our life forever because it is part of our journey. It simply organizes patterns and regularities in the world. By the means of exists in everything that our eyes, our world will not be formed with the help of mathematics as the source of measuring something that is existing. A lot of events happen around us in the blink of an eye. Several children have already been born. Liters of water have been consumed, or thousands of tweets have been posted. For us to make a census of all available information, we need mathematical tool help us make sound analysis and better decision. So by that, let us have our example. Mathematics help organize residential electricity consumption. Mathematics is very effective to know the amount of household that using electricity and determine the amount of every usage of every electronics devices and appliances. It is also applied to detailed investigation to form electrical analysis containing valid and true details in every household. Next, mathematics helps predict the behavior of nature and phenomena in the world. Predict the size, location, and timing of natural hazard and virtually impossible, but because of the help of mathematics, we are able to forecast calamities such as hurricane, floods, earthquake, volcanic eruptions, wildfire, and landslide, etc. Example, sa mga oras na to ay makulimlim sa pamamagitan ng pakikinig sa balita, telebisyon o radyo. Malalaman natin na kung may bagyo or may masamang panahon. Halimbawa, sa Biyernes o sa Sabado, maglalandfall ito sa kung saan sa parte ng Pilipinas. We would be to predict, or we could be able to know when occurrence happens. So based on historical patterns, meteorologists can make forecasts to help us prepare for our day-to-day activities. They also can watch us of weather disturbances that can affect our activities for weeks. Ayon kay Nathaniel Mangtani Cruz, doon sa 24 oras, batay sa kanyang weather forecast, sa umaga ay mainit at pagsapit ng hapon ay makulimlim na. Mayroong pagbugso-bugsong ulan, and also by that we can prepare for it. Kukuha tayo ng payong or raincoat in case umulan, and also we can cancel our different activities like mountain climbing or camping, you will cancel because there is a chance that it will rain. It gives us a way to understand pattern to quantity relationships and to predict the future. Math help us understand the world, and we use to understand math the world in interconnected very everyday. Math show this connection and possibilities. The earlier young learners can put this skill practice, the more likely we will remain in innovation society and economy. Next is mathematics helps control nature and occurrence the world for own ends. Mathematics is one of most important aspect in our daily lives. It helps us tell time, assist us in finances, engage us better problem solving skills, and help us to understand the world. Better mathematics is spreading across the universe. You could see it almost everywhere. Through the tallest building in the world up to the smallest details of particles. Mathematics help in controlling nature and occurrence because some of them behave mathematically, like snowflake. That is a perfect example of a fractal, a building that is confused of constructive measurements to stand taller, and microscopic that is composed of zero and ones to regulate the process. These are just example reminding us that mathematics is a very strong soul or origin of everything. Humans are good at counting things, then adding, subtracting, dividing, and multiplying so that equation can be formed to explain every piece of physical three-dimensional matter. If the equation do not equal zero, then little bit of matter can be subtly and so elegantly shaped into instant so that all the equations of that particular concept will be the same. Law, order, and symmetry will work well in creating a homogeneous isotropic universe of heat and entropy that can be worked it. There is some of type of occurrence we will discuss. Climate change is a long-term shift in global or regional climate patterns. When climate change refers specifically to the rise in global temperature from the mid-20th century present. Then 16 to stop climate change. First, recycle. Second, make your community green. Third, be native with energy usage. Fourth, get active and both fit educate yourself and others. And the last, encourage the use of renewable energies.
Another topic by Mr. Andre Alison Dumitita.
Mathematics has numerous applications in the world, making it indispensable. Why is the mathematics is indispensable? Mathematics makes our life orderly and prevents chaos. Certain qualities that are nurtured by mathematics are power of reasoning, creativity, abstract or spatial thinking, critical thinking, problem-solving ability, and even effective communication skills. What are the applications of mathematics for our world? Managing money, balancing the checkbook, shopping for the best price, preparing food, figuring out distance, time, and cost for travel, understanding loans for cars, trucks, homes, schooling, or other purposes, understanding sports, being a player or team, statistics, playing music. Mathematical language and symbols. Characteristics of mathematical language: precise, concise, and powerful. Precise, able to make very fine distinctions. A number with more digits after the decimal point, for instance, 1.233443322 is more precise than a number with similar value with fewer digits after the decimal point, like 1.2334. For example, the value of pi is 3.14159265359. Approximately, a number which is precise and accurate is 3.14159265359. Concise, able to say things briefly. Powerful, able to express complex thoughts with related ease. Power of a number says how many times to use the number in a multiplication. Powers are also called exponent or indices. For example, 8 raised to 2 could be called 8 to the power of 2, or 8 to the second power, or simply 8 squared. Expression versus sentences. An expression is the mathematical analog of an English noun. It is a correct arrangement of mathematical symbols used to represent a mathematical object of interest. An example of a mathematical expression with a variable is 2x plus 3. All variables must have a coefficient, a number that is multiplied by the variable. In the expression 2x plus 3, the coefficient of x is the number 2, and it means 2 times x plus 3. A mathematical sentence is the analog of an English sentence. It is a correct arrangement of mathematical symbols that states a complete thought. A mathematical sentence, also called mathematical statement or proposal, is a sentence that can be identified as either true or false. For example, 6 is a prime number is a mathematical sentence or simply statement. Of course, 6 is a prime number is a false statement. Conventions in the mathematical language. Mathematicians abide by the conventions in order to allow other mathematicians to understand what they write without constantly having to redefine basic terms. 4 basic concepts: sets, functions, relations, and binary operations. Set is any collection of objects or elements, which may be mathematical or not. For example, the set of integers from 1 to 100 is finite, whereas the set of all integers is infinite. A set is commonly represented as a list of all its members enclosed in braces. Function. In mathematics, an expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable. Functions are ubiquitous in mathematics and are essential for formulating physical relationships in the science. A relation is a relationship between sets of values. In math, The relation is between the x values and y values of ordered pairs. The set of all x values is called the domain, and the set of y values is called the range. Binary operation on a set is called calculation that combines two elements of the set called operands to produce another element of the set, meaning a binary operation on the set of real numbers is a rule which combines any two real numbers a and b and gives a real number.
Another topic by Mr. Christian Belen.
And now I'll discuss some of mathematics language and symbols. Formality. A scientific theory is called formal when it is expressed in a form, usually mathematics, such that there is no ambiguity as though meaning and implication if it's expressed. For example, "I'll see him tomorrow" will have different meaning when uttered by different people or on different dates. On the other hand, the expression "Karen Jones will see John Smith on October 13, 1992" will normally always refers to the same event independently of person, moment, or circumstances. Problem solving. Inductive and deductive reasoning. Inductive and deductive reasoning are two fundamental forms of reasoning for mathematicians. The formal theorem and proof that we rely today all began with these two types of reasoning. Inductive reasoning is reaching a conclusion based on a series of observations. A conclusion that is reached by inductive reasoning may not be valid. For example, when you notice that all mice you see around you are brown, and so you make the conclusion that all mice in the world are brown, can you say for certain that this conclusion is correct? The answer is no, because it's based just on few observations. Deductive reasoning. Inductive reasoning typically leads to deductive reasoning, the process of reaching conclusion based on previously known facts. The conclusion reached by this type of reasonings are valid and can be relied on. For example, you know for a fact that all pennies are coppered color. Now, if your friend give you a penny, what you can conclude about the penny? You can conclude that the penny will be copper colored. You can say this for a certain because the statement is based on fact. Intuition, proof, and certainty. Intuition or intuitionism, opposed to the pre-intuitionism, is an approach where mathematics is considered to be purely to the result of the constructive mental activity of human, rather than the discovery of fundamental principle claimed to exist in an objective reality. Proof is an inferential argument for a mathematical statement in the argument. Other previously established statements, such as theorem, can be used. In principle, a proof can be traced back to self-evident or assumed statement known as axioms along with accepted rule of inferences. Certainty is a perfect knowledge that has total security from errors or the mental state in being without doubt. Objectively defined, certain is a total continuity and validity of all potential injury to the highest degree of precision. Something is certain only if no criticism can occur. Polya's 4 steps in problem solving. Polya 4 step in problem solving mathematics. George Polya construct a specific system used to approach problem solving, known as the Polya 4 steps problem solving process. Learn to understand the problem, devise a plan, carry out the plan, and look back on the work. Understanding the problem. Understand the problem. State the problem in your own words. Pinpoint exactly what is being asked. Identify the own. Figure out the problem till you is important. Identify any information that is irrelevant to the problem. In our example, we can understand the problem by realizing that we don't need the information about the gender of the guest or the color of the cupcake. That is irrelevant. All we really need to know is that we are being asked,
how many cupcakes are left of the total that were made? So, we understand the problem.
Devise a plan. Now that we understand the problem, we have to devise a plan to solve the problem we call. Look for a pattern, review similar problem, make a stable diagram or chart, write an equation, use guessing and checking, work backwards, identify a sub-goals. In our example, we need a sub-goal of figuring out the actual total numbers of cupcake made before we can determine how many were left over. We could write an equation to show what is unknown and how to find the solution. 1 dozen plus 3 dozen minus 5 equals numbers of eaten. Third is carry out the plan. Carry out the plan, the third step in the process, is the next logical step. Carry out the plan. When you carry out the plan, you have keep a record of your step as you implement your strategy from step 2. So 1 dozen plus 3 dozen minus 5 equals number eaten. Obviously, we will need the prior knowledge that 1 dozen equals 12. 1 times 12 equals 12 times 3 times 12 equals 36. So what we really have is 12 plus 36 minus 5 equals number eaten. 12 plus 36 equals 48 and 48 minus 5 equals 43. The last part is look back, check and interpret. Look back, can you check the result? Can you check the argument? Can you derive the results differently? Can you see the result in a glance? The example that meet the number of cupcake eaten is 43. Some topics on problem solving is discussed by Miss Alea Faye Fason.